Let's now take a look at the second part of this question where we are supposed to consider q minus 3r dot q minus 3r. And in order for us to find the value of lambda, we need an equation for here. So we need to fill in the blank here. Can you guys take a look at your theory outline and then find for me exactly which result that we have just discussed that will allow us to form an equation for this so that we can solve for lambda. Any suggestion? And for those of you who are online, can you type into the chat? Let me know what is your opinion. Can you find that result that we have just discussed that we can apply to this so that we can form an equation? Okay. Okay, Nuru has a suggestion. Okay, and Nuru, you are correct. We are going to be making use of the algebraic properties that we have discussed in dot product, correct, Nuru? So Nuru is talking about this part of our outline. Can you guys turn to this part also? In dot product that we have just discussed, under this section here, number 2 is the one that we can be making use of. Because number 2 says that when a vector dot itself, it is going to be modulus of that vector square. So when a vector dot itself, this is going to be modulus of q minus 3r square. And from the previous part, q minus 3r is lambda p. So this is how we can introduce lambda into the equation. And on the left hand side, we are going to apply number 5. Number 5, it is like multiplication, expansion. So it will be q dot q. Let me write it down here. So we have a q dot q, and then this dot this is minus 3 of q dot r. This dot this is minus 3 of r dot q, and this dot this is plus 9 of r dot r. In fact, I have been using number 4 here. Number 4 here says that if there were to be a scalar multiple to a vector, when you do a dot product, that scalar multiple can be brought outside the dot product. So when I took q dot minus 3r, I took out minus 3. Similarly for this, I took out minus 3. Definitely for this also, we took out minus 3 times minus 3, so we have a 9. And in fact, this, if I were to make use of number 1 here says that a dot b is equal to b dot a, which means that for this, it is the same as q dot r. So now working it out, q dot q, once again making use of number 2. Making use of number 2, this is modulus of q square. And since this q dot r is the same as r dot q, so we can rewrite this as minus 6 of, let's just go for q dot r. And I have a plus 9 of modulus of r square. This is going to be equal to modulus of lambda square, modulus of p square. Do you have any question? Any question, guys? Okay? Okay, let's continue. So now we can make use of the information that is given to us by the question. Modulus of q, according to what the question says, it is modulus of q is 5. So 5 square minus 6. Q dot r, it is going to be equal to modulus of q, modulus of r, cosine of the angle that is between q and r. The question says that it is cosine inverse 5 over 6. So here we will have a cosine inverse 5 over 6 plus 9 times of modulus of r. And the question tells me that this is 2. So 2 square. This is going to be modulus of lambda square is the same as lambda square, right? So lambda square. And modulus of p, according to the question, p is a unit vector. So this is going to be 1 square, which means that lambda square is going to be equal to 5 square minus 6 times of 5. Modulus of r is 2. Cosine inverse of 5 over 6 is 5 over 6 plus 9 times of 2 square. And lambda square here is going to be equal to 11, which means that lambda is equal to plus or minus square root of 11.